Welcome to RR Max channel. We are continuing with our reduction formula. This will be episode 9. Please do subscribe and give me a motivation to proceed with my videos. I'm continuing with the problems. We take up this problem, evaluate I m comma n is equal to integral of x to the power of m log x whole power n dx. M comma n both are positive integers. Hence or otherwise evaluate integral x power 4 into log x whole power 3 dx. Now I'm going to integrate this using integration by parts. So we have called I m comma n is equal to integral x power m into log x whole power n dx. For us, we'll have to choose something as u and dv for integrating by parts. We always take that one which is easy for differentiation as u and which is easy for integration as dv. So here I will take u as log x because it's easy for my differentiation. So du is equal to log x whole power n. So you get du is equal to n log x whole power n minus 1 into differential of log x is 1 by x into dx. Now you take dv is equal to x power m dx. On integrating you get v is equal to x power m plus 1 by m plus 1. Now you use your integration by parts uv minus integral v du. You substitute, you get uv, that is x power m plus 1 by m plus 1 into log x whole power n minus integral v du, which is x power m plus 1 by m plus 1 into n into log x whole power n minus 1 into 1 by x. Now this denominator x will cancel with 1 here in the numerator where you have x power m plus 1. So that reduces to x to the power of m. So now this reduces to x power m plus 1 by m plus 1 into log x whole power n minus n by m plus 1 are constants will come outside, integral of x power m into log x whole power n minus 1 dx. Now this is in the original form, so you can rewrite this as I m comma n minus 1. So you have your reduction formula here. I m comma n is equal to x to the power of m plus 1 by m plus 1 into log x whole to the power of n minus n by m plus 1 into I m comma n minus 1. Now the last integral, because this n is reducing, your last integral will be I m comma 0, which will be integral of x power m log x whole power 0 will be 1 into dx. So on integrating you get x to the power of m plus 1 divided by m plus 1. Now you are asked to evaluate integral x power 4 into log x whole cube dx. So that is nothing but I 4 comma 3. So m is 4 and n is 3 in this particular formula. You just substitute. So 4 plus 1, so it becomes x power 5 by 5 into log x whole cube minus 3 by 5 I 4 comma 2. The next level will be 4 comma 2. So that means m is 4 but n is 2. So you have this x power 5 by 5 log x whole cube minus 3 by 5 into, in the brackets you substitute for I 4 comma 2, that is x power 5 by 5 log x whole square minus 2 by 5 I 4 comma 1. So now we will substitute I 4 comma 1 as follows. So now I 4 comma 3 becomes x to the power of 5 by 5 log x whole cube minus 3 by 5 into, I am using a curly bracket here, x power 5 by 5 log x whole square minus 2 by 5. I am substituting for the I 4 comma 2. So that 4 comma 1. So you get this as x power 5 by 5 log x minus 1 by 5 I 4 comma 0. I 4 comma 0 is just x power m plus 1 by m plus 1, which is x power 5 by 5. So you substitute that also and you get your I 4 comma 3. I am removing all the brackets now. X power 5 by 5 log x whole cube minus 3 by 25 x power 5 log x whole square, minus and minus becomes plus here. 3 2s are 6, 5 into 5 here. So that gives you 125 x power 5 log x Now this is negative, negative, negative. So this becomes negative, and that gives you 3 into 2, so 6. Here you have 5 into 5 into 5 into x power 5 by 5. So 4 fives, that means that will give you 625. So it will be minus 6 by 625 x power 5. I'm taking out x power 5 by 5 as a common factor. So you get x power 5 by 5 into log x whole cube minus 3 by 5 log x whole square plus 6 by 25 log x minus 6 by 125. So this is your final answer. I will take up another problem similar where I just do the substitution alone. Okay. So the next problem that I take is evaluate integral log x whole power 5 x power 5 dx. Then using the same formula I m comma n is equal to integral of log x whole power n x power m dx. You had the formula x power m plus 1 by m plus 1 log x whole power n minus n by m plus 1 I m comma n minus 1. In this case m and n both are 5. So you have I 5 comma 5. So you substitute here, you get x power 6 by 6 log x whole power 5 minus 5 by 6 into I 5 comma 4. So I 5 comma 4 will be, now you have m is 5 but n is 4. So you get x power 6 by 6 into log x whole power 4 minus 4 by 6 I 5 comma 3. Now you calculate I 5 comma 3. Now m is 5, n is 3. So you get x power 6 by 6 log x whole cube minus 3 by 6 I 5 comma 2. So you go for I 5 comma 2, m is 5, n is 2. That gives you x power 6 by 6 into log x whole square minus 2 by 6 I 5 comma 1. So I 5 comma 1 will be x power 6 by 6 into log x minus 1 by 6 I 5 comma 0. So I 5 comma 0 is equal to integral of x power 5 dx, which is x power 6 by 6. Now you keep substituting everything backwards. So this will come here, you the whole thing you substitute here, the whole thing you substitute here, etc. And you do the simplification. You get I 5 comma 5 is equal to, you can take out x power 6 by 6 as a common factor, will give you log x whole power 5 minus 5 by 6 log x whole power 4 plus 5 into 4 by 6 square log x whole cube minus 5 into 4 into 3 by 6 to the power of 3 log x whole square plus 5 into 4 into 3 into 2 by 6 power 4 log x minus 5 factorial by 6 power 5. So you can simplify, you can cancel terms, etc. So that gives you x to the power of 6 by 6 into bracket, you have log x whole power 5 minus 5 by 6 log x whole power 4 plus 5 by 9 log x whole cube minus 5 by 8 log x whole square plus 5 by 54 log x minus 5 by 324. This is your final answer. Let's see the next type of problem. Next problem that I take is find the reduction formula for integral of x power m divided by log x power n into dx. So now I am having a log x in the denominator. To simplify this, I call this as I m comma n, and I am going to multiply my numerator and denominator with an x. So that I comma n becomes integral of x to the power of m plus 1 divided by x into log x whole power n dx. Now we are going to use integration by parts. Now this time I will take u as x to the power of m plus 1. Because when I take log x, I have 1 by x here. So that is easy for integration. So this time u will be taken as x to the power of m plus 1. So du is m plus 1 into x power m dx. So dv will be integral of dx divided by x into log x whole power n. So put log x is equal to t. That means you get 1 by x dx is equal to dt. So when this dv will now become integral of dt by t to the power of n, and when you have the numerator it is t to the power of minus n. So when you integrate that, you get t power minus n plus 1 divided by minus n plus 1. So replace your t, so that gives you 1 by 1 minus n into log x to the power of n minus 1. So use integration by parts here. So I m comma n is equal to uv. So that gives you x power m plus 1 into 1 by 1 minus n into log x whole power n minus 1 minus integral v du. So that gives you m plus 1 into x power n divided by 1 minus n into log x to the power of n minus 1. So now this you change 1 minus n, you remove a minus sign. So that becomes minus into n minus 1. So that minus comes here, which is x to the power of n plus 1 divided by n minus 1 into log x to the power of n minus 1 plus same negative sign I am removing for 1 minus n. So making this as a positive sign gives you m plus 1 by n minus 1 into I m comma n minus 1. So this will be your reduction formula for integral of x power n by log x whole power n dx. Let's see the next problem. If in is equal to integral of dx by x square plus 1 whole power n, show that 2n into in plus 1 is equal to 2n minus 1 in plus x by x square plus 1 whole power n. Hence, find integral 0 to 1 x by x square plus 1 whole square dx. Now, if you see this problem, they have called in, so that n stands for the denominator, but in the answer you have in terms of in plus 1. Okay, so we'll have to see what happens here. So let's see, let's take u is equal to x square plus 1 to the power of minus n. So du is minus n into x square plus 1 to the power of minus n minus 1 into 2x dx. dv is dx, so v is equal to x. You are integrating by parts. In is equal to uv, so that gives you x by x square plus 1 whole power n plus integral of x into, it becomes plus because when we differentiated we got a minus n. That negative sign I've used here in the integration by parts negative sign. I've clubbed the 2 and made it positive. So you get x into 2nx divided by x square plus 1 to the power of n plus 1 dx, because the numerator when it comes to denominator negative sign goes. So now what happens here is you have 2n is a constant, you have x square here. So you add and subtract 1 in the numerator. So it becomes in the integral of 2n into x square plus 1 minus 1. So x square plus 1 you take it as one term and minus 1 you take it as a second term. So this becomes x by x square plus 1 whole power n plus 2n into integral of x square plus 1 divided by x square plus 1 to the power of n plus 1 dx minus 2n into integral of 1 by x square plus 1 to the power of n plus 1 dx. So 1 x square plus 1 gets cancelled here. So this becomes in here and this becomes in plus 1. So this you have it as x by x square plus 1 whole power n plus 2n in minus 2n in plus 1. Now you want the answer as in plus 1 is equal to, so you bring this 2n in plus 1 to your left hand side, and what in you have there you bring it to the right hand side. So you get it as 2n in plus 1 is equal to 2n minus 1 into in plus x by x square plus 1 whole power n. You are asked to evaluate integral 0 to 1 x by x square plus 1 whole square dx. Now this I cannot apply the formula directly here. So I make a substitution. X is equal to tan theta. Why I use tan theta is because my denominator has 1 plus x square term. So 1 plus tan square is known to me. So I take x is equal to tan theta. So that 1 plus x square that will become 1 plus tan square will lead to secant square theta. Now here dx is the secant square theta d theta. Now when x is 0, you substitute here tan theta should be 0, that means theta is 0. When x is 1, tan theta should be 1, so theta is 45, which is pi by 4. The integral 0 to 1 x by x square plus 1 whole square dx now becomes integral 0 to pi by 4 tan theta divided by 1 plus tan square theta the whole square into secant square theta d theta. Now this is 1 plus tan square is secant square, whole square will become secant to the power of 4 theta. So you can cancel 1 secant square in the numerator and denominator, giving the integral as integral 0 to pi by 4 tan theta by secant square theta d theta. Now convert this in terms of sine and cos. So you get 0 to pi by 4. Tan theta is sine theta by cos theta, and secant square theta is 1 by cos square theta, which comes to the numerator as cos square here, and 1 cos theta gets cancelled. So leaving you with integral of 0 to pi by 4 sine theta cos theta d theta, which can be rewritten as integral 0 to pi by 4 sine 2 theta divided by 2 d theta. So integrating sine 2 theta, I get minus cos 2 theta by 2. There is already a 2, making it as 4, and you substitute limits from 0 to pi by 4. You are substituting theta as pi by 4, so 2 times pi by 4 will become pi by 2, and cos pi by 2 is going to be 0. And the lower limit you need a negative sign, so that is minus of cos 0 is 1, so you get 1 here. So minus 1 by 4 into 0 minus 1, which will reduce to 1 by 4. So that's your final answer. So we'll stop here and continue in our next episode. Please subscribe this channel. Thank you.